Now we have seen about the lithium molecule, right? We are going to see about the carbon molecule first. Carbon and oxygen molecule we have to see respectively. But then about the hydrogen bonding already we have learned yesterday. So I don't want to repeat it. These two molecules we will see today in details. Okay. So see what is given about this. Fine. So here for the carbon molecule, electronic configuration of carbon is 1s2, 2s2, 2p2, correct? Yes. There are 12 electrons in the C2. The electronic configuration of C2 molecule would be what? Therefore, it will be C2, sigma 1s2, sigma star 1s2, sigma star 2, sigma 2s2, sigma star 2s2, because sigma star 2s2 it would be a nearby. Then pi 2px2, which is equal to pi 2pyz, and it is also would be written in this manner: kk sigma 2s2, sigma star 2s2, pi 2p2x, which is equal to pi 2pz2. Okay. So to understand this in detailed manner, I'll show you the diagram. Wait. Otherwise, you may feel like what's going on. It's completely different, which we have learned earlier. It's not like that. I asked you to take a screenshot yesterday for the sequence, right? Yeah. I hope you took the screenshot for that. Yeah. Here is the energy level. So these are the two sequences which you need to note down. Please note down on the paper. Energy levels, electrons would be filled in this manner. Electron would be going to the, see what energy energy of a various molecular orbital for O2 and F2 is given below. And here it is what? However, this sequence energy levels of molecular orbital is not correct for the remaining molecules like lithium, beryllium, boron, carbon, nitrogen. For these, this sequence you need to follow. Okay, what is basic change in between that we need to check. Okay, see the first one here, sigma 1s, then sigma star 1s, sigma 2s, sigma star 2s, then sigma 2pz is less as compared to sigma 2px is equal to sigma 2py. And here pi star 2px is equal to pi star 2py. And then sigma star 2pz. Okay, so this is nothing but a energy sequence. It is applicable only for the fluorine molecule and the oxygen molecule. Please note it down. And the next one is what? For lithium, beryllium, boron, carbon, and nitrogen molecule, the sequence which you're supposed to follow would be sigma 1s, sigma star 1s, then sigma 2s, sigma star 2s, then 2px is equal to pi 2px is equal to pi 2pz. Then sigma 2pz means what? It would be the reverse over here. Okay, it would be the reverse. Then sigma star 2px is equal to, sorry, pi star 2px is equal to pi star 2pz, and then sigma star 2pz. Means rest all things are same, only this sequence you need to change. Means this equal orbital would become first and sigma 2pz would become later. Understand? Only this need to be swiped for lithium, beryllium, boron, carbon, and nitrogen molecule. And for the fluorine and the oxygen, sequence would be in this way. Clear? Understood? Will you please write it down? Have you wrote? Fine. Okay. Now see what is given for the molecule of oxygen and molecule of carbon that we are going to check. Yeah. For the carbon molecule, lithium molecule, Lithium molecule already we have seen, so that won't be that problematic. But then we'll go for the carbon molecule now. See what is given in this. Electronic configuration of one carbon is 1s2, 2s2, 2p6. So one carbon atom has how many? 6 electrons. And when you're forming the molecule of carbon, it will be 6 plus 6 is equal to how many? 12 electrons. Correct? Yes. So the electronic configuration of C2 molecule, we have to fill how many? 12 electrons in that. And we have a sequence in that we're supposed to fill the electrons. That what? Sigma 1s2, sigma star 1s2. Then sigma 2s2, and then pi 2px2 is equal to pi 2p by 2. Okay. And in short, we can write it kk, right? This would be what? Electronic configuration for restore. Sigma 2s2 from here. Sigma 2s2, sigma star 2s2, and pi 2px2 is equal to pi 2p y2. Okay. So the bond order of the C2 is 1/2 into 8 minus 4. So bonding, wherever star is there, that will be the anti-bonding. Okay. And wherever star is not given, that would be the bonding molecular orbital. If you see here, 1s2, 2 electrons. Then here also 2 electron, anti-bonding 2 electron. Again here 2 electron in anti-bonding. Correct? Then how many? Here it will be what? Bonding, that would be the 4 electron. Correct? 4 and 2, 4 and 4, 8 minus 4. That will be equal to 2. And when you divide it by 2, what you'll get? Bond order would be 1 or 2? 1 or 2? Come on, tell me. What would be the bond order over here? See, how many 8 electrons would be there in a bonding molecular orbital? 4 electrons would be into anti-bonding molecular orbital. Okay, 8 minus 4 remains 4. And 1/2 into 4 is equal to 2. So bond order would be 2. Okay, and C2 should be diamagnetic. Why? Because all electrons are pair. You can see 2, 2, 2, and 2. There won't be single electron present in that, and hence it is diamagnetic in nature. Right? Have indeed been detected in the, where it been detected? Paper fix. It is important to note that the double bond of C2 consists of both pi bonds because of the presence of 4 electrons in 2 pi electron orbital. In most of the other molecules, a double bond is made up of sigma bond and a pi bond. In the similar fashion, the bonding in N2 molecule can be discussed. In the same way, N2 molecule also can be discussed. So I'm just going to write down that sequence. Give me a while. Okay. Just a minute. Whiteboard is visible to you now? Yes. Yeah, give me a while. So we have seen the carbon-carbon molecule, right? Carbon molecule, C2 molecule. Okay. For C2 molecule, which sequence we are going to follow, that I supposed to write over here, right? First of all, you should know the electronic configuration for one carbon. Electronic configuration for one carbon would be what? 1s2, 2s2, 2p2, correct? Yes or no? Yeah. So this is for one carbon atom, right? And if C2 molecule, there would be 2 carbon atoms, correct? And because of that, you will get the diagram in such a way that 3. Here also 1, 2, 3. Correct? How it will be split? Now, how energy levels would be split, that we have to check first of all. Here it will be for the 1s electron. This electrons we have to write in a separate manner. See the way how I supposed to write it. If you can, you please write it down simultaneously with me so you'll understand it in a better manner. So if you have a 1s orbital, that would be written separately over here. This will be 1s. This is also 1s orbital, correct? This is the energy graph. Right? These are the atomic orbital. These are also atomic orbital. And after mixing these two, you will get the molecular orbital, right? So molecular orbital would be here. Molecular orbital would be here. And after mixing, you will get here molecular orbital. Atomic orbital and molecular orbital when mixed together, you will get what? Molecular orbital. This will be molecular orbital. This is also molecular orbital, right? This would be sigma 1s. This is sigma star 1s, correct? Yes. So how many electrons are there in 1s orbital of 2 carbon? That would be 2, right? Here it will be 2, isn't it? Yes. So these two will be go 2 over here and 2 over here. This is a part of the diagram. This would be the part of diagram. Then the next one, what? We have p orbital. In that p orbital, we know that there means like if you see this p orbital, you will get what? 3 orbitals are present into the p. That would be px, py, and pz. Okay. Among that, one would be different and two would be same. Among that, what? One would be different and two would be same. In that, pz has a high energy, right? And px and py have a same energy. This you need to keep it in your mind. Fine? Okay. Now, how you're going to split it? These orbitals would be split in this manner. Suppose here would be the 3 orbitals. 1, 2, 3. Here also 1, 2, 3 orbital. How it will be get distributed, how it will be converted into molecular orbital, that we have supposed to see. Here it will be 2. Here also it would be 2. Right? Then you have your 2px and 2pz orbital as well. That too need to be checked. Isn't it? In a sequence, we're supposed to write it in that way. So after that, what it will be? We are writing right now for the carbon, right? So this has a less energy. So your electron would be filled into this first. That will be what? 2px2 or pi px2, and it will be pi py2. Clear? Now, sure. Apart from that, another energy would be, another electron would be jump into the 2pz. Correct? And 2pz has an energy more as compared to this electrons, pi electrons. So it will become here as a molecular orbital. It will be what? Your 2pz2. Okay? Or 2pz only. Number of electrons we will see later. How many electrons to be filled over here. Apart from that, how many electrons would be comes here? This would be the star. Pi star 2px, pi star 2py. And here your another molecular orbital. That would be what? Here 2pz star. Correct? Sigma 2p, sigma 2pz star. Clear? sigma star actually. This will be the sigma to pz, and that will be the sigma star to pz. So in this sequence, electrons should be filled. So this you understood. 2s also you might have understood in same way it will be filled. Now what else remain? How many electrons are there in p orbital? Only 2. Here 1, here 1, and here 1. Here also 1 and here 1. So total 4 electron. Among that 2 will be go here. Isn't it? 2 electrons would be go here and another 2 would be come here and pair up this. Correct? Yes or no? So what would be the electronic configuration for your carbon? This is empty, this is empty, this is empty. So that need not to show. So electronic configuration for the carbon would be what? That will be, check over here. Electronic configuration of carbon is C2, which is equal to sigma 1s. How many electrons are there? 2. Then sigma star 1s. It is also contain 2 electrons. Then sigma 2s 2. Then sigma star 2s2, right? Yes or no? Total 12 electrons to be filled. How many happen? 2 and 2, 4, 5, 6, 7, 8. Right? 4 more are remain. Those will goes to this pi 2px. Right? It has a 2 electron, and pi 2p y, it also has a 2 electron. Up to this only your electronic configuration, because this does not have any electrons, this does not have any electron, this does not contain any electron. So this would be the electronic configuration for your carbon, right? Yes or no? And in that, what you come to know, beta, here there won't be any single electron present. One electron is not present. Here 2, here 2, here also 2, here also 2, here also 2, and here also 2. As there is no single electron is present in this, it will be diamagnetic in nature. Its magnetic property would be diamagnetic in nature. It won't be paramagnetic. Fine. So this is about carbon molecule. Clear? And bond order, if you have to calculate how many electrons are there into the, how you calculate the bond order? Bond order is equal to 1/2 into bonding electron minus anti-bonding electron, right? Bonding electron minus anti-bonding electron, which is equal to what? Wait a minute. Plug in कर बेटे वहाँ पे लगा ये लगा और स्विच ऑन करना बटन लगे चालू बटन चालू कर हाँ लगा वहाँ पे हाँ लगा बटन चालू कर वेरी गुड रहने दो ठीक है गॉट इट यस श्रेयसी हेलो Tracy, are you there? Fine. So because of that, it's a diamagnetic. Now you can check number of bonding electron. This is bonding. Wherever star is there, na, that star is nothing but anti-bonding. Okay. And wherever star is not given, that would be the bonding. So here it is anti-bonding. Here it is also anti-bonding. So out of 12, 4 are become what? Anti-bonding. So bonding would remain how many? 8. So here we can come to know 1/2 8 minus 4. So that is equal to 1/2 into 4, which is equal to 2. So carbon-carbon bond has a bond order 2. So whenever multiple bond is formed into the carbon, one of the like bond form, that would be the pi bond. In most of the other element, that can be sigma and pi bond together. But then in case of carbon, there would be pi bond as a double bond. Okay. And you can see the electrons also jump into the pi bond here. This is pi px and pi py. Okay. Clear? Understood? Any query? Okay, fine. I'll erase it and we'll see the another molecule that would be the N2. Now for N2, the same scenario would be there, right? Nitrogen, its atomic number is 7. Electronic configuration 1s2, 2s2, 2p how many? Now 4, 5, 6, 7, 2p 3, correct? Yes? Yeah. So how many electrons are there total? 7. And if you have to form the N2 bond, right? So total number of electron would be how many? 14. So 14 electron you should feel. Now for the nitrogen, the diagram which we have followed for the carbon, same diagram we have to follow for the nitrogen as well, right? So this would be the energy graph, right? Here it will be the 1s, then 2s, then 2p, 2p. Okay. In 1s again, it will form these are the atomic orbital. These are the atomic orbital. These are the atomic orbital. It will form the molecular orbital. Here will be the molecular orbital. Here also would be molecular orbital. Then for the 2s also, here is a molecular orbital. Here also molecular orbital. Fine. Then 1s, 2s. And here for 2p, there would be the same way. Here two molecular orbitals with the same energy. And here only one. And same anti-bonding also would be formed. Fine. Now these are what? Sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. This would be what? Pi to px, pi to py. And here sigma to pz. Right? Here. Now it is pi to pi star to px, pi star to py. And this will be sigma to pz, but then it will be star because it's anti-bonding, right? So wherever mediator line, that lines above orbitals would be anti-bonding, okay? And which require a less energy, and those are situated below, they are bonding molecular orbital, okay? These all things you need to keep it in your mind. Now, what would be the sequence? How many electrons you should feel? Total 14 electron, right? Here would be how many? 2 electron, 2 electron. It will be goes directly here. 1, 2, 3, 4. Correct? Here also 2 electrons are already present. 2 electrons are already present. So it will also go here. Correct? Total how many happen? 4 and 4, 8 electron has been gone. Now remaining how many? 3 electron in the P. Correct? 1, 2, 3. Here also how many? 1, 2, 3. So 3 and 3 how many? 6. So it will go over here first. 1, 2, 3, 4, 5, 6. Because bonding orbital would be filled first and then it will go to the anti-bonding molecular orbital. Isn't it? Yes or no? Let me check. Just confirm it once. For the nitrogen, we just have to see the sequence. Yes. 2px, 2py will first fill, then it will go to the sigma to pz, then it will go to the anti-bonding in the same way. So what would be the electronic configuration? Electronic configuration of N2 molecule. It will be here. You will get sigma 1s2, then sigma star 1s2. Then sigma 2s2, sigma star 2s2, correct? Now remaining what? Here, pi equal to pi to py. This is 2 and this is also 2. And then here it will be what? Sigma to pz. Wait a minute. Yeah. Sigma to pz2. Correct? So this would be the electronic configuration for N2. Now here you can count the number of bonding and anti-bonding electrons. So this is anti-bonding, this is anti-bonding. So how many? 4 are anti-bonding and remaining are what? Bonding. Means 2 and 2, 4, 5, 6, 7, 8, 9, 10. 10 would be the bonding. So bond order is equal to 1/2. Here 10 minus 4, which is equal to what? 1/2 into 6. That is equal to 3. You come to know nitrogen molecule has how many bonds? Triple bond, 3 bonds. Hence bond order is 3. Got it? Yes. And as there won't be any single electron present together, hence means like any of the orbital does not contain any single electron, unpaired electron, and hence it is diamagnetic in nature. This all about what? Your nitrogen molecule. Now, if I ask you for the oxygen molecule, what you will do? Oxygen molecule. Oxygen molecule, oxygen, atomic number 8, electronic configuration, 1s2, 2s2, 2p how many? 4. Correct? Yes. So total number of electrons you're supposed to fill for the O2 molecule is equal to what? 16. Right? 16 electrons you should fill. But then sequence is quite different in this case. For oxygen and fluorine, we have to follow a reverse concept. Like whatever we supposed to do for the sigma to pz and pi to px and pi to py, we just have to do it in reverse way. Correct? I'll let you know how. Diagram, rest thing would be same. How we have drawn earlier in the same way we supposed to draw. Only the change is what? We have to swipe up 2 orbitals. How I'll let you know. This would be your 1s. 1s orbital. Okay. Atomic orbital. It will form a molecular orbital over here. This is also 1s. Then 2s, it will also form a molecular orbital over here. And here 2p. It gets segregated in the same way. But then the basic difference in between what? The sequence would follow. First of all, it will go to the sigma to pz. And then your for 2p. Here it will form the 2pz first. And then the 2 orbitals which have same energy. Only this sequence has been reversed. Rest all things would be same. These are also 2p. Okay. Here then first pi electron and then the sigma 2p z. Okay. So sequence it says what? Here it is sigma s, sigma 1s, sigma star 1s. Then this is sigma 2s, sigma star 2s. This will be what? sigma 2pz, then here pi 2px, pi 2py. This is pi star 2px, pi star 2py, and this is sigma star 2pz. Okay, these are the electrons. So these are the orbital, molecular orbital, which has been formed. And this sequence we have to follow for the O2 molecule. What we have done in this, we just have swipe up these two. These two has been swipe up from the previous diagram. Previously, we have written these two energy orbitals like pi 2px and pi 2py before sigma 2pz. But then in oxygen and fluorine, it will be jump above, and pi 2px and pi 2py has a greater energy as compared to 2pz. And because of that, it lying below the 2pz. Okay, that you need to keep it in your mind. This sequence you need to follow for writing the electronic configuration. So what would be the molecular electronic configuration? We know that 1s has a 2 electrons, here 2 and here also 2. Okay, so it will be filled these orbitals, right? Unless and until it won't be pair up, electron will not go to the next orbital. Keep it in your mind. Here also 2s has 2 electrons. Here also 2s has 2 electrons. That will be come first of all at the ground, and then it will go to the excited. Means first of all bonding orbital should be filled, and then electron will be jump into anti-bonding. That also you need to keep it in your mind. Then the next here, how many? 4 electrons this side, 4 electrons that side. So total how many electrons are there? 4 electrons are there. So it will be happen here. First 2 electrons goes into the 2pz. 2 electrons goes into the 2pz. Then 3, 4, 5, 6 electron goes into the 2px and pi 2px and pi 2py, and remaining 2 will be going to this single electrons will go into this 2px and 2py. Clear? Yes? Understood or not? Yes? Fine. Now what happened in this case? If I have to write the electronic configuration for O2 molecule, how I'm going to write it for O2 molecule? Electronic configuration would be sigma 1s2, then sigma star 1s2, right? Sigma 2s2, sigma star 2s2, correct? Then here it will be what? Electrons goes first of all into sigma to pz2, then here pi to px is equal to pi to py. Both has 2 electron each, right? And then electron would be jump into another electronic condition, that is pi star to px1, which has an energy equal to pi star to py1. So you can come to know in this, see, 1 electron is present into pi star to px and pi star to py. Means it contains a single electron, and hence O2 molecule is paramagnetic in nature. If double bond, 2 electrons would be present, that time it would be what? Diamagnetic. If single electron would be present, that time it will be paramagnetic in nature. Now, one more thing I would like to explain, bond order for the O2 molecule. So that we need to check. Bonding molecular orbital would be what, and anti-bonding would be what. So this is the anti-bonding. This is also anti-bonding, right? And these are also anti-bonding. So total how many? 2 and 2, 4. 4 and 2, 6 are anti-bonding among the 16, correct? Yes or no? Yeah. So bond order you need to calculate for the O2 molecule. That would be what? That will be 6 electrons should be there, no? I think. How many? 6 electrons are there, right? Anti-bonding, yes, 2, and this 4, 6 electrons, right? And bonding would be 10. So because of that, bond order is equal to 1/2 10 minus 6. You can check. These are 2 electrons, these are 2 electrons, and these are 2 means 6 electrons. Then rest are 10. So 10 minus 6, and hence 4 by 2 is equal to 2. So oxygen molecule is formed by oxygen-oxygen double bond. Okay, fine. Any query? Anything is there in your mind not understood, then let me know. O2 molecule should be paramagnetic, and the prediction that correspond to the experimental observation. Right? Yes. So same you have to do it for the fluorine molecule. Let me see whether you're able to do it or not. Only one electron, one more electron would be jump in this. A diagram would be same manner. Only this would become 2. This is also would become 2. So bond order you have to calculate by yourself, whatever it would be, because it become 8, I guess. Number of 8 anti-bonding electrons would be get 10 minus 8 is equal to 2. 2 by 2 is 1. So fluorine bond would be possible with single bond, right? Yes or no? And one more thing, fluorine molecule would be diamagnetic in nature. How it will be? Diamagnetic in nature. So the sequence we should keep it in our mind. That would be the feeling of electron, the way how supposed to feel it. Okay. This diagram need to be followed only for oxygen and fluorine molecule. And if you just swipe up these orbitals, that can be followed for C2, then boron, means B2, then Be2, then the carbon, then the lithium. Okay, for these all things, even including nitrogen, it's like that swipe up diagram can be used. Understood? Any query? Only for the oxygen and fluorine, you just have to swipe up the 2 orbitals. That sequence, if you keep it in your mind, you're able to find out the like nature, magnetic nature, bond order, bond length, everything you're able to calculate for any of the molecule. And this was your chapter for chemical bonding and molecular structure. It's very easy. And if you practice it properly, it will be really very like interesting, and you will enjoy it. Understand? You will enjoy it. Fine. Shall I clear it? Fine. If you have any doubt, anything about it, please let me know. So I'll post few questions regarding this today itself. Okay. And upcoming Sunday test would be there on the same chapter. So prepare it and please appear for the test. Okay. And I'll declare this chapter finished over here. If you have any doubt regarding, please let me know so I can clarify it. Okay. And apart from that, next period, I'll start with the new chapter. Yeah. Anything with you? You want to share something? If it is, so let me know. Shreyasi. Okay, fine. So you understood the concept. It's very easy. Just 2 sequence you have to keep it in your mind. And according to those sequence, you have to feel the electrons. That's it. Nothing is there in that. Okay, fine. Shall I end the class now? Fine. Take care. Bye-bye.